You're welcome to my channel. It's another day for some chemistry lesson. Today we shall be discussing alkyd resin synthesis. And before then, we all know what a resin is in relation to the paint industry. Now it is worthwhile, let's get to know what a paint is, then get to discuss alkyd resin synthesis. A paint is just but a mixture of ingredients, being resin, a pigment, solvent, or even additives, which when applied on a surface, dries by either oxidation, evaporation, or by polymerization to offer protection and to decorate the substrate, which is the painted surface. For the purpose of this presentation, we shall be dwelling on resin synthesis, precisely alkyd resin synthesis, which is a very vital ingredient for the paint industry. Now, what is a resin? A resin is just but a binder and a polymer material that forms a network of structure. You can call that a matrix. And this network holds the respective components of the paint or pigment to provide cohesion, that's between the ingredients in the paint, and adhesion, that's for the paint to adhere or stick to the substrate when applied on that particular surface. If there were no resin, paint could deform either by chalking or by peeling off, and there are several different types of deformation of paint due to the use of a bad binder, that's a resin that is not suitable. So we can call a resin to be a binder in the paint industry. Without a resin, there would be no paint. We have three major classifications of binders. Just as we've said, a resin is a binder. So we have three major classifications of a resin. And we can also address a resin to be a polymer. So one, we have acrylic resin, we have alkyd resin, and we also have epoxy resin. Now I'm going to break down the formation of these resin. How can they be synthesized? Then we dwell on the alkyd resin synthesis. Acrylic polymers are those that are used as binders, especially in emulsion paints. Emulsion paints are water-based paints, okay? Based on homopolymers or copolymers. We know what homopolymers are. They are polymers that are made from same monomer. So example, we can have polyethylene, and we also have copolymers that's from different monomer. Epoxy resin or binders, or you can call them polymers, are made from 1-chloro-2,3-epoxy propane from 3-chloropropene and a substituted phenol. Example is bisphenol A, going by this equation of reaction. So this is just the epoxy resin network or matrix of structure that helps to bind the components of the paint to form an adhesive solid. For the purpose of this presentation, we shall be dwelling on the alkyd resin synthesis. Now, alkyd resin are made from polyols such as glycerol. For example, we have the propane 1,2,3-triol with a dibasic acid anhydride, that's phthalic anhydride of phthalic acid. example is benzene 1,2-dicarboxylic acid, which is actually a dibazic acid, and a drying oil. Now these components are heated together to form ester bonds in which water is released as byproduct. Alkyd derived its name from alcohol and anhydride. Now, how are alkyd resins synthesized in the laboratory? There are two processes that could be employed in the alkyd resin synthesis. One, we have the alcoholysis process, which we can also call the glyceride process. Secondly, we have the fatty acid process. Now, for the purpose of this presentation, I shall be dwelling on the alcoholysis process and the procedure stages to be employed in carrying out the alcoholysis process. Now, for the two stages I've just mentioned, the two processes I've just mentioned, the alcoholysis process and the fatty acid processes, they all have in common a certain procedure. And these are the three common procedures you have to take to prepare your resin. One is preparation of the resin using lead oxide as catalyst, or you could prepare the resin using calcium oxide or preparing the resin by esterification method. Amongst this procedure, I shall be explaining the preparation of the resin using calcium oxide as catalyst. Now, here are the major reagents needed. In my next video, I'll be explaining and showing how to calculate the various alkyd resin grades, that's the oil length, for 40%, 50%, and 60% respectively, by employing the particular drying oil's iodine value, which must be in the range of 115 to 190. And for the purpose of this presentation, we shall be dwelling on the 50% oil length recipe. The alkyd resin calculations would give you an insight to how much of the acid anhydride, the glycerol, and the drying oil you have to weigh exactly for the alkyd resin synthesis. So for the 50% alkyd length, I'm going for making a 300 gram paint formulation. So from my calculation, I need 90.59 gram of acid anhydride, that's benzene 1,2-dicarboxylic acid, and I need 59.41 gram of the glycerol, that's the propane 1,2,3-triol, and my drying oil, I need about 150 gram for the 50% oil length alkyd resin grade. So these are the apparatus we would be needing for the synthesis. We need a mechanical stirrer, we need a weighing balance, a 3 or 4 necked round bottom flask, a heating mantle, an inert gas, nitrogen, thermometer, we need some beakers, some burette, retort stand for titration, filter funnel, and other apparatus that we might just want to employ. For the synthesis of the alkyd resin, first we need to prepare the resin using calcium oxide as catalyst, and we have two distinct stages. So the first stage is called the monoglyceride process. Now, for a 50% oil length alkyd resin grade of total weight 300 gram, we get to add 59.41 gram of glycerol, followed by 150 gram of the extracted drying oil and 0.3 gram of calcium oxide, which would serve as the catalyst, into a 3 or 4 neck round bottom flask. Now, 0.3 gram of calcium oxide serves as 0.1% of the catalyst. So for your calculations, when done, you add 0.1% of the catalyst introduced into the round bottom flask. Then you get to set up the apparatus as shown like this. Bear in mind that we need an inert gas, nitrogen, because the reaction should occur or must occur in an inert atmosphere to avoid or to prevent oxidation. For a three-necked round bottom flask, we must ensure to make provisions for the passage of the inert gas, the thermometer or aliquot withdrawal. At some point, you have to withdraw some portions from the reaction mixture to test its solubility in methanol, and for the mechanical stirrer, well fitted to stir vigorously the reaction mixture. Now switch on the heating mantle fitted with the 3 or 4 necked round bottom flask incorporated with the gas inlet and the mechanical stirrer, and ensure that the system is well closed. The reaction progress should be monitored so closely to avoid violent reactions within the system. So at some point in time, you might need to reduce the mechanical stirrer speed or reduce the heat coming from the heating mantle. The whole reaction should last to about 4 hours. But before then, you have to carry out some tests to actually get to determine for the formation of the monoglyceride. Now bear in mind that the drying oil is a triglyceride. So in a nutshell, what you're trying to do is to heat the components glycerol and the drying oil to convert the triglyceride of the oil to a monoglyceride. So that is why it is called a monoglyceride process. So for you to determine that the formation of the monoglyceride is reached, you have to be drawing aliquots. Withdraw some portions from the reaction system at intervals for about 30-40 minutes. Then you get to test its solubility, just a little portion. Each time you're withdrawing, close the round bottom flask valve immediately, then test its solubility in methanol. Whenever you observe a clear solution that has total solubility, that is the point at which the monoglyceride has been formed. Now, the second stage involves the addition of benzene 1,4-dicarboxylic acid, which is the phthalic anhydride, a exact measured amount of 90.59 gram for a 50% alkyd resin oil length, and we are going for about 300 gram formulation. So 90.59 gram of phthalic anhydride would be introduced to the cooled mixture, followed by the addition of 30 gram of xylene, which represents 10% of the total alkyd resin weight. That is 10% of 300 gram formulation is 30 gram. So xylene should be 30% of the total alkyd resin weight. Now, what is the function of xylene? Xylene aids the removal of water of esterification. Bear in mind that we are adding an acid to an alcohol, okay, which would eventually form an ester, and water would be removed in the process. So xylene helps to remove the water of esterification from the glycerol, initially from the monoglyceride stage, added to the phthalic anhydride, which is an acid. So reaction between an acid and an alcohol is an esterification one. So removal of water, xylene does the whole work. This second stage is very critical and has to be monitored very properly. Now, it is even more expedient and very much simplified to use a 4-necked round bottom flask. This is the reason. In this particular stage, we'll be fitting a din and stock to the round bottom flask. And also bear in mind that we'll also be fixing the inert gas inlet to the round bottom flask, including the mechanical stirrer, and we should also have another valve for introducing or withdrawing aliquot from the reaction system. Just as we've seen from the previous stage, the monoglycerate process, we had to determine the solubility of the aliquot withdrawn from the reaction mixture in methanol to mark the end of the monoglycerate process. Now, for this stage, we wouldn't be doing that. Instead, we'll be determining the drop in acid value. Bear in mind, we just added, or we would be introducing, or we have introduced an acid into the reaction mixture, which is a phthalic anhydride. Okay, and then we would have to determine its drop, which should fall significantly to about 10 milligram per potassium hydroxide, that is acid value. Once the system is switched on, the heating mantle is switched on, the mechanical stirrer, the nitrogen gas is passed. Once all the fittings are installed, once the setup is completed again, now you have to withdraw aliquot at intervals of 30 minutes, starting from 0 minute, which you should time. So at intervals of 30 minutes, you get to withdraw aliquot, which you would test for its acid value. Now, you get to collect aliquot, just as I've said, from 0 minutes, 30 minutes, 60 minutes, 90 minutes, 120, 150, 180, till you get a drop in acid value to about 10 milligram per potassium hydroxide. Now, you get to collect aliquot in the volume range of 0.5 ml to 0.65 ml from the reaction mixture, starting from 0. Same thing you do after 30 minutes, just as said. Now, after withdrawing this aliquot, make sure you close the round bottom flask valve. Then titrate this volume you've collected against 0.1 molar potassium hydroxide using 0.5 gram of phenolphthalein indicator, which is dissolved in a mixture of 1:1 ratio of ethanol and toluene, followed by 25 ml water, that's distilled water. The table of values you would obtain from the titration for the individual times, 0 minute, 30 minutes, up to about 180 minutes, depending to when you have the drop in acid value to about 10 milligram per KOH, that's potassium hydroxide, should look like this. In the same vein, you are also supposed to note the corresponding volumes of water that's been removed at those respective times, 0 minute, 30 intervals. This volume of water being removed can be used to calculate further, and the acid values can be used to also obtain other significant parameters.